Today we're talking about variation, and we're going to start with direct variation. So recall that direct variation is a linear function of the form y equals k times x, where k is the non-zero constant of variation. So you're going to want to make sure that you remember that k is the non-zero constant of variation. So in each exercise, y varies directly with x, so find the missing value. So for number 1 here, we can know that we have y varying directly with x. And so at y equals 3 when x is 2, find x when y is 5. So we're going to start with y equals 3 when x is 2. So we're going to substitute 3 for y and 2 for x, and we're going to solve this now for k. So we're going to take each side and divide it by 2. And when we do that, we end up finding that k is equal to 3/2. So now we can rewrite our equation and say y equals 3/2 x. And so now we need to find x when y is 5. And so we can substitute 5 in for y and now solve for x. And so we want to multiply everything by 2. So I'll cancel those out. So we end up getting 10 equals 3x, and then divide each side by 3. And so we get that x is equal to 10/3 as our final answer. So now we have, if y is -4 when x is 1/2, find y when x is 2/3. So again, we have direct variation, so y equals k times x. And we are going to start with when y is 4, x is 1/2. So -4 equals k times 1/2. We're going to solve for k by multiplying each side by 2. And so that gives us -8 equals k. So we rewrite our equation as y equals -8x. And so now we need to find y when x is 2/3. So we're going to leave y because we're solving for y. Then we have -8 times 2/3. And -8 times 2/3 gives us y equals -16/3 as our final answer. So now we have, if y is -14 when x is -7, find x when y is 22. So again, direct variation, so y equals k times x. And so we have y is -14 equals k times -7. Solving for k, we're going to divide each side by -7. And so that gives us 2 equals k. So we rewrite this as y equals 2x. So now find x when y is 22. So we have 22 equals 2x. And we're going to solve for x by dividing each side by 2. And so we get 11 equals x as our final answer. And so now we move on to inverse variation. And so we want to remember inverse variation is a function of the form y equals k over x, or x times y is k, where k cannot equal 0. And so suppose that x and y vary inversely. We're going to write a function that models each inverse variation. And so we have the first question is 3, -5. So you're going to remember that's an xy pair. And so now we know that x equals 3 and y equals -5. And so x and y vary inversely, so we're using y equals k over x. We're going to substitute -5 for y, and we're going to substitute 3 for x. Now we solve for k by multiplying each side by 3. And so we end up getting -15 equals k. So then we can rewrite our equation as y equals -15 over x, and it says just to write the function, so that's our final answer. Now we have 0.3 and 1.4, so that's x and that's y, and so we're using inverse variation, y equals k over x. We're going to substitute these in, so 1.4 equals k over 0.3. We're going to multiply each side by 0.3. So those cancel. And we end up getting here that k is equal to 0.42. So then we rewrite our equation as y equals 0.42 over x. And that's our final answer. Now we have x is 7, y is 4, and it's still inverse variation. And so we can say 4 equals k over 7. We're going to multiply each side by 7. And so that ends up giving us 28 equals k. So we can write our final answer as y equals 28 over x. Lastly, we're going to combine variation, which combines direct and inverse variation. And so if we go to y varies directly with the square of x. So y varies is y equals, directly is multiplication, with the square of x is x squared. So if we write this equation out, we get y equals kx squared. So y varies directly with the square of x. Now y varies, so y equals inversely is division with the cube of x, so x cubed. So we get, as our equation, y varies inversely with the cube of x. So then we have z varies, so z equals jointly with x and y, means you're multiplying with x and y. So that ends up giving us that z varies jointly with x and y. Next we have z varies jointly. So z varies jointly is multiplication with x and y, and then inversely is division with w. So if we go to our equation, we get z varies jointly with x and y and inversely with w. And lastly, we have z varies directly multiplication with x and then inversely division with the product of w and y, so multiplying w and y. So we write our equation, we get z varies directly with x and then inversely with the product of w and y. Now it says write the function that models each relationship and then find z when x is 4 and y is 9. So we have z varies directly with x and then inversely with y. So we have x is 6, y is 2, and z is 15. So 15 equals k times 6 over 2. I'm going to start with simplifying 6 over 2. So that gives me 15 equals k times 3. Now divide each side by 3. Those cancel. And so you end up getting that k is 5. And so then from here, we can write our equation again. So we get z equals 5x over y. And then it says find z when x is 4 and y is 9. So we're trying to find z when x is 4 and y is 9. And so we get z equals 20/9 as our final answer. Now we have z varies jointly with x and y. So z varies jointly with x and y. We know that x is 2, y is 3, and z is 60. So 60 equals k times 2 times 3. 2 times 3 is where we'll start. And so we get 60 equals k times 6. Now divide each side by 6. And you get that 10 is k. And so then we can rewrite this as z equals 10xy. And so remember, we need to solve for z when x is 4 and y is 9. So then z equals 10 times 4 times 9, which gives you that z equals 360 as your final answer. then z varies directly with the square of x and inversely with y. We know that x is 2, y is 4, and z is 3, so 3 equals k times 2 squared over 4. Let's start with the 2 squared. So we get 3 equals k times 4 over 4. And so then 4 over 4 will cancel and simplify, which gives us that 3 equals k. So we can rewrite that as z equals 3x squared over y. And then we find z when x is 4 and y is 9. So z equals 3 times 4 squared over 9. And so when you solve that out, you end up getting that z is equal to 16/3. And now we have z varies inversely with the product of x and y. And so x is 2, y is 4, and z is 1/2. So when we substitute all those in, so I'm going to start with the 2 times 4 here, which gives me 1/2 equals k divided by 8. Now I'm going to take each side and multiply it by 8. And so I get 4 equals k. So I rewrite this as z equals 4 over x times y. And I need to find z when x is 4 and y is 9. So z equals 4 over x is 4, y is 9. 4 over 4 here will cancel out with each other, which leaves us with z equals 1/9 as our final answer.